Okay, how's everybody doing today? Okay, good, good, good. If you would get out the notes that we've been looking at the past couple of days, we're actually going to have the opportunity to spend more time today looking at some of these equations, figuring out how to solve them. While you guys are doing that, remember in a couple of days, what's happening on Monday? Okay, so you got your test. Okay, it will not cover solving trig equations though. This material is not going to be on there. It will cover the sum of difference identities. It'll have the double angle identities. Majority of it's multiple choice. You can use your notes. I did put a few, one or two open-ended questions on there. And you remember on the homework where we had to verify it, we chose one side of the equation, used our identities to show the other side. I put a couple of those on there as well. Okay, that involve either the sum of difference identities or the double angle identities. So that's coming up on Monday, and then we will just continue to see how far we can get next week. I'm actually not 100% sure if I'm going to see you guys next Wednesday or not, because what's happening on Wednesday? The SAT, and I know for sure I'm administering it, but I don't know how long it's going to take. Ms. Brady was telling me 5 hours, and if that's the case, then I probably will not be seeing you that day. But I'm actually going during lunch. That's when we're having our training for it, and I'll have a little more information.
Seniors don't have to be here, right?
It's actually, yes, they're not giving us a late start day. So from what I understand, if you're not taking the SAT, you'll still be going to your classes like normal. Now, I don't know if you're going to have them in those classes or if they're going to be put in, say, the dining hall. People will be meeting there. Yeah, hopefully they'll tell us all that information in just a little bit when I go to the training. But, yeah, tomorrow would be a normal school day. Or, sorry, next Wednesday will be a normal school day if you're not taking the SAT. Okay. Yeah, not tomorrow, not tomorrow. It's the 6th of March. Tomorrow is the 1st of March. Okay. And tomorrow's a normal school day, yes. Okay, normal Friday. All right. I think that's all I have, unless anybody has any questions. Did anybody have the homework they wanted to turn in? I have the key. Oh, if you already turned it in, then you're good. If you didn't turn it in yesterday, that's what I'm looking for.
When's the STAR test?
Now, this class doesn't have an EOC.
I know, I just don't want to show up with this.
Oh, I actually don't know. When are the EOCs scheduled? Like, is usually end of April, beginning of May, somewhere around there, when we're big into testing season? Okay. All right, well, let's go ahead and take a look at our equations. So I'm going to go ahead and continue to talk to you guys about these problems using the triangles, but if you have your unit circle, you can also use that. That's really, really helpful when you're solving these. We've been talking about two types of triangles, okay, special right triangles. What kind am I referring to? Okay, the 45, 45. 90 and the 30, 60, 90. Okay, because if you're able to draw a triangle, I'm guaranteeing that all of the equations, okay, it's going to be one of these two. Now, if you can't create a triangle, then that means it's got to be a quadrantal, and we'll actually have some of those coming up. Maybe not today. We'll kind of see how tomorrow works out. But in a 45, 45, 90 triangle, remember, this was isosceles, so that means the two legs are what? The same length, yes. So we go ahead and say those are x and x. That's one big identifier if you're going to say this is a 45, 45, 90. But what do I do with that leg in order to get the hypotenuse? Multiply by the square root of, not 3, 2. There we go. Okay, so that's the relationship in a 45, 45, 90. For a 30, 60, 90, let's say x is across from 30. What do I multiply by x to get the longer leg? This is where you multiply by the square root of 3. There we go. So the longer leg is square root of 3 times as long as the shorter. And Nathan's correct now. How do we get the hypotenuse? We double the shorter leg. Okay. And then what was that phrase that I taught you in order to remember where the trig functions were positive? All students take calculus. Okay, very good, very good. All right. Now, there's one thing I haven't shown you yet. Typically, these problems are going to ask you to find your answers within one revolution between 0 and 2 pi. So typically, that's going to be one positive revolution, right? But if it asks you to find all the answers, like every answer that's possible, you have to think, well, how many times can I continue to rotate using the unit circle? You can rotate an infinite number of times. So that means you could potentially have an infinite number of answers that are going to make it true. Thank you. Okay. All right. So you could also rotate clockwise. Again, infinite number of answers. So what we do is we go ahead and add an expression to the end of it. So let me go back over here. Okay. You remember on this very first example, we got our two answers to be pi over 3 and 5 pi over 3. Okay. Well, those are two answers within one positive revolution between 0 and 2 pi, right? But if I wanted an expression to give me every single answer that ever existed, well, what I would do is take, for example, pi over 3, and I would add 2 pi in. We're going to say that n is an integer. Remember, those are your positive counting numbers, 0 and the opposites. So you have 1, 2, 3, and so forth, -1, -2, -3. Those would take care of your revolutions. Okay. Now, why do you think it's in multiples of 2 pi? How far is one revolution? We know it's 360 degrees, but how far is it as a radian? It's always 2 pi, right? So the other answer would be 5 pi over 3 plus 2 pi n. Okay. Now, I'm going to go ahead and show you one more thing, and we'll get to an example. If you have an equation where you're solving for sine, cosine, secant, or cosecant, and you want the general answer, meaning you want every possible answer there is, for those, you're going to add 2 pi n. But you'll notice there are some trig functions missing there. What are the two that I didn't write? Tangent and cotangent, right? So if you're solving a problem that has tangent or cotangent, okay, you're not going to add 2 pi n. Could anybody tell me what we will add? Think about it like this. If I were to look at the graph of sine, cosine, secant, and cosecant, what's the period for all four of those? How long does it take before it starts to repeat again? It is 2 pi. But the period for tangent and cotangent is not 2 pi. It doesn't take a full revolution for it to repeat. Does anybody remember how long it takes? Oh, not pi over 2. We're close. Forget about the 2. Just pi. It only takes half as long for it to go ahead and repeat itself. So for these four, I would add plus 2 pi n, but for tangent and cotangent, I would simply add pi n, where we're going to say that n is an integer. Okay. So there may be some problems if you're not given an interval. If you're not given that interval between 0 and 2 pi in the instructions, this is the general form you'll want to put. If it does give you the interval, well, then you'll just go ahead and write the answer like we have been. Okay. Well, let's get to a problem. Let's see what we think. Okay. Number 3. Let me move this over here. So I've got sine of x plus square root of 2 is equal to negative sine of x. Okay. So for this one, let's say I want to go ahead and get all answers. Basically, I want an expression or expressions that would give me all the infinite answers I could possibly get. Okay. So this one's not an interval. Well, you'll notice this time we have more than one trig function, but is it the same or different? Is it the same trig function or is it different? Let's see, this one's sine and this one is sine. So they're both the same. That means they're like terms. So that means I can combine those. Imagine if this equation said x plus the square root of 2 is equal to negative x. Well, I'd want to go ahead and isolate x, get x by itself. Okay, so I'd probably add the x over. So that would give me 2x plus the square root of 2 is equal to 0. And then I'd subtract the square root of 2, right? Okay. Well, we're going to do the same thing, but just with the trig function. If we can combine trig functions, that's probably a really good idea. And it doesn't matter how we do it. I can take this sign here on the left, I can subtract him over to the right, or I can take this negative sign and I can add him to the left. What would you prefer to do? Add. Okay. So I'm going to add sine of x here plus sine of x here. So a negative sign plus a positive sign, those cancel. So sine plus sine will give me 2 sine of x plus the square root of 2 equals 0. Okay. Everything you used to do when solving an equation is exactly what you're going to do here. Okay. You're just dealing with a trig function. Now, what did we do a moment ago? Let's subtract the square root of 2. So minus the square root of 2 minus the square root of 2. Okay. So 2 sine of x is equal to negative square root of 2. Well, just like I want to get the equation to read just x equals, if I have a trig function, what do you think I want to rewrite it to show? What do I want to get by itself? I want to get sine of x by itself. So we're close. What do I do now? Divide by 2. So those 2's are going to cancel. So now I have sine of x is the negative square root of 2 over 2. There you go. This is where you're now going to turn to your triangles to help you find those answers. Okay? Because once you've got that trig function by itself, now I'm looking for that specific ratio. Now, we'll go ahead and compare it to the unit circle in just a second. Okay? So let's think about this. All students take calculus. So what 2 quadrants will sine be negative? And why am I asking you about negative? Because this fraction's what? Because it's negative, right? So it's going to be negative where? In 3 and 4. So in quadrant 3, I'm going to draw that terminal side connected to the x-axis. In quadrant 4, I'm going to do that connected to the x-axis. Where you place your triangles depends on the sign of your fraction. If you look back at the very first problem we did, okay, see this was equal to a positive 1/2, so we had it in quadrants 1 and 2. Okay. All right, so let's see here. What is sine's ratio? I keep forgetting those things. It's always y over r, right? Okay. So the y value, remember we always do it from the reference angle's point of view. So this would be a negative square root of 2 with a radius of 2. The opposite negative square root of 2 with a hypotenuse of 2. Okay, a radius of 2. Now, I need to find that x value because I want to know, is this a 30, 60, 90 or is it a 45, 45, 90? So how am I going to find this x right here? Let me go ahead and label it. Pi what? Pythagorean theorem. So let's see, I'm going to say x squared plus the negative square root of 2 squared is equal to 2 squared. I'm just taking the 3 sides and plugging it into the theorem, right? Okay. Well, what happens when you square a square root? They cancel. We know a negative is going to go positive, so this would be x squared plus 2 is equal to what? 4, 2 squared. Okay, so subtract 2. So x squared is equal to 2, but I want x. So it's going to be square root. So what's this length right here? It's the square root of 2. Okay. So this one's got to be the square root of 2 as well. But there's something I'm missing. What am I missing? A little sign. Why? Negative where? Why? Because of the quadrant it's in. See, in quadrant 3, both x and y are negative, right? Now remember, both these triangles will always be identical. Same angle measures, same side lengths. We're just saying this one's negative because of the direction you got to go. Okay. Well, what do you recognize this as? Would it be a 30, 60, 90? Or is it a 45, 45, 90?
45.
This is a 45, 45, 90. So I know this angle is 45. I know this angle is 45 degrees. Now, we always start rotating from the positive x-axis until we hit those sides. Like that guy right there, half of it is 180, right? Oops. So what's 180 plus an additional 45? 225. So this is 225 degrees. That's an answer to this equation. Now I want to start here, and I want to go all the way around to here. Okay. So think of it this way. Instead of trying to go all the way around, think about what's 360 minus the 45. Okay. It'll be what? 315 degrees. So 315 degrees. There we go. Here's the only thing we have left to do. I want to take these degree measures, and I just want to go ahead and change them to radian measures. Well, what's 225 degrees as a radian measure? How do I change anything to a... There we go. Times pi over 180. So somebody help me out. Basically, I need 225 over 180. What would that reduce to? And we can do this in the calculator. I don't know if mine will actually give me the ratio. If this will pop up here. Let's see. 225 divided by 180. There you go. Oh, it does come to 5/4. Okay. There we go. So this first answer right here is 5 pi over 4. That's 225 degrees. Okay. So now what's 315 degrees? That's 7 pi over 4. Okay. But now, this one, I said I wanted every answer possible. Every coterminal angle. If I continue to rotate and rotate around and around and around. Okay. So what is it that I'm going to add on the end here? Would it be plus 2 pi n or plus pi n? Why 2 pi n? What trig function do I have? Sine. So that would be plus 2 pi n. Okay. There you go. Just like that. Now, take a look at the unit circle, and a lot of people probably already figured this out by the time it took me to create these two triangles. We found 225 and 315, right? This is where we should have a y value of a negative square root of 2 over 2. So if I look at the unit circle, okay, well, here's 225 5 pi over 4. That ordered pair has a y value of negative square root of 2 over 2. If I look at the other location, we said the answer was 315 or 7 pi over 4. That's where we have another y value of negative square root of 2 over 2. Okay. Now, you're probably thinking, okay, you know, why am I going to have to deal with the triangles? Why is that necessary if I can just look on the unit circle? And you're absolutely right. But what if you come across like a tangent or a cosecant or a secant problem? Then you don't get those directly off of the unit circle. Okay, the triangles are really going to help you out at that point. Okay, right, Rosie? Okay, all right. Okay, so let's try another example here. Now this one. Okay, let's go ahead and say we want to solve this on the interval from 0 to 2 pi. Okay, and it's a cosine equation, right? So would I have to add 2 pi n to my answers? What do you think, yes or no?
Yes.
No. If it gives you an interval, if it says solve on this interval, you won't be adding the 2 pi n or the pi n. If it does not give you an interval, that's when you want to go ahead and put the general form. Okay. Now, I think the biggest thing here is just going to be for people to manipulate this. So in this case, they could read cosine equals. Okay. Can someone help me out? Let's go ahead and pretend that this was 18x minus 7 equals 14x minus 5. How you would solve this for x and make it x equals is exactly what you're going to do to this equation here. Okay. Can anybody come on up and help me with that portion of it? Lilybell, you want to show me? She wants to show me. It's going to equal 3? Okay. Who will do it? So many hands going up. I know there's a lot of people who want to come up, but we only got one. Oh, okay. Lilybell will do it. Yay. Yeah, so just treat cosine of x like a variable. Minus 7 equals 14 cosine x minus 5. So you're going to add the 7. Oh. So 4 cosine x equals positive 2. And what is 2 divided by 4? That is perfect. That is exactly right. Okay. That's exactly what we should get. She should get it down to cosine of x equals 1/2. Okay. Now, let me go back and kind of elaborate on what she did here, because the board jumped and it kind of went a little crazy there for a second. Okay. So there are like terms that I can combine. I can combine the 18 cosine x with the 14 cosine x, and I can combine negative 7 with the negative 5, right? It does not matter which one you want to move. I think the first thing she did was to move 7, right? So if I add 7, and she did it at the same time, I'm going to go ahead and take it one step. So these cancel. So I've got 18 cosine of x is equal to 14 cosine of x what? Negative 5 plus 7. Plus 2. See, that's where she got the 2 from. Then she decided, I'm going to take the 14 cosine and I'm going to pull it to the left. But how did she do that? Did she add or subtract? She had to subtract. So minus 14 cosine of x, minus 14 cosine of x. Okay. Those are going to cancel. So remember, these are like terms. So what's 18 cosine minus 14 cosine? That's 4 cosine x. Equals, the only thing we have left is a 2. Okay. Now what'd she do? She divided by 4, yes. So when those cancel, she had cosine of x is equal to 1/2, 2 divided by 4. And that's really what I'm just trying to emphasize here. Everything you would normally do when solving an equation is exactly what you do here. Okay, yes, ma'am. Actually, you know what? Because you came up and did that, go for it. Okay. I guess I could say you're in luck. Get it? That was a P joke, yeah. Here, well, if Trump were listening to this, he would really like that. Oh, she walked away. Okay. Get it because of the Russian PP tape?
Oh.
Okay. Yeah. You know, I'd make another joke, but it'd be pretty crappy. So I'm just going to keep going. How about that? There you go. There we go. Okay. Okay, so cosine of x equals 1/2. And then we would do, like I've been showing you with the triangles, in order to go ahead and solve this. In fact, is this positive or negative? The 1/2. It's positive. So what 2 quadrants would cosine be positive? 1 and, not 2, 1 and 4. So I'd draw one like this, and then one like this. Okay. But doesn't cosine of x equals 1/2? Doesn't that look familiar? Look earlier in your paper. Isn't it the second problem that we already solved? Yeah. So we'd already solved cosine of x equals 1/2. Okay. In fact, the answers we got, trying to remember, that was 60 and 300. So what was that? Pi over 3 and 5 pi over 3? Okay. So see, we've already solved it, but you can see how a different looking equation simplified down to a same expression that we'd already looked at. Does that make sense? Okay. All right. I think the hardest part for a lot of folks is going to be getting down to that last step where it's cosine equals, sine equals, things like that. Okay. All right. Well, let's move on. Okay. So let's try this. 4 sine squared of x minus 1 equals 0. Okay. 4 sine squared of x minus 1 equals 0. Now you'll notice I've only got one trig function, right? It's only sine. So I want to rewrite this equation so that all I have is sine of x equals whatever I'm going to end up with. Okay. So think of it if I had 4x squared minus 1 equals 0. Walk me through the steps. How would I get x by itself? What would I do first? Add 1. Okay. So I'm going to add 1. So that's 4x squared is equal to 1. And then I would do what? Divide by 4, right? So then I would have x squared is equal to 1/4. And how would I get x from x squared? I would then take the square root. Okay. Now, let's go back to the original. Everything we just did, I'm just going to now do with sine there. So I'm still going to add the 1. Those cancel. So 4 sine squared of x equals 1. What do we do next? Then we divide it by 4. Those cancel. So sine squared of x equals 1/4. Okay. And it doesn't matter that it's a squared trig function. How would I get sine from a sine squared? Take the square root. Okay. So what do you think the square root of sine squared is? It's just sine. Now, when you take the square root of a fraction, this actually means you can take the square root of both parts. So what's the square root of 1? 1. Square root of 4? 2. But there is something that we're forgetting. When you take an even root when solving an equation, there's something you got to put in front of your value. It's like a symbol. Oh, not I. It's not imaginary. What are 2 little symbols I need to put there? Plus and minus. That's exactly right. Okay. Plus and minus 1/2. Okay. Now, think about this. You've got both positive and negative. In what quadrants would sine be positive or negative? Well, let's see. What 2 quadrants would sine be positive? 1 and 2. Where would sine be negative? 3 and 4. So you'll notice in my diagram here, how many triangles have I drawn? 4. Remember, a really good rule of thumb, the number of triangles you draw, that's the number of answers you're going to get. But on this one, why don't we go ahead and make it easy? Okay. All I'm looking for is a positive or a negative 1/2. But it has to be the y value, right? So let's go to the unit circle. Okay. I'm looking here on the unit circle. I need ordered pairs where a y is a 1/2 or a negative 1/2. What's one of them? Pi over 6. At pi over 6, there's a positive 1/2. So pi over 6 is a solution. Okay. Is there another location? Remember, how many should there be? There should be 4. Okay. 5 pi over 6. There's a positive 1/2 as well. Where else? Okay, 7 pi over 6, because that is a negative 1/2. And what's the last one, Marcus? Okay, 11 pi over 6, there's another negative 1/2. There you go. Now, if I were to run through the triangles as I've been showing you, would we still get the exact same answers? Yes. Okay. This is what it means to solve these trig equations. Is there anybody who's not sure what I'm doing? Anybody who's not sure where these answers are coming from? Anybody confused? Okay, Brandon, you okay?
Oh yeah, I just figured I'd get them on the
Yeah, just look at the ordered pairs. Okay, that works out very nicely. Okay, good. All right, so I'll tell you what, why don't we go ahead and stop there for today, because we actually had the opportunity to work several problems. Okay, you guys did a good job.